All right, welcome everybody. I'm really pleased to see so many people interested in what probably is one of the most unscientific and boring topics that you can think of, cooperation in science. Well, why am I saying that? I think I'm saying that because, of course, when you're talking about cooperation or collaboration, you may ask, well, that's not really science. It's a means to an end. It's a means to reach scientific outcome, but it's not. Let's say it's not a real topic by itself. It's something that facilitates something else, and still it is something that has kept myself busy at least for the last 15 years, surprisingly, and that's probably why we decided to have this introduction on strengthening cooperation. From my side, I should give you a little bit of background. As you have seen, I am representing UTIMA. We are a strategic research management company situated not far from here in Vienna. And what we do is we design research strategies for public organizations, ministries, but also for research institutes, for universities, for faculties, and also for industry, typically large industry, but occasionally also small and medium-sized enterprises. We cover different topics of research funding, so a lot of what we do is managing complex research projects, so typically when there are more than 30 participants, for example, in a project, and we do a little bit of research PR, including information dissemination actions, and also related to innovation recently. And we're doing this mostly in the area of information and communication technologies, but also in biotechnology. And here you can just see a few of our clients. So what I just mentioned, ministries, universities, the European Commission, obviously, but also large and small industry, and a lot of research institutes as well. Why collaborate? I've tried to visualize here with a picture what is nowadays diagnosed by philosophers of science as what is currently happening in our society. We are moving towards a post-scientific society. What does that mean? The post-scientific society would be a society where science is not unimportant, but it is becoming oriented more towards innovation. So more towards putting, well, results of scientific and technological research out on the markets and being successful with them in the markets. And there is no doubt that you can see this development, for example, in the framework program of the European Commission. What used to be very much focused on research is now focused on innovation, at least when you read the program. Whether that's going to happen in the projects themselves remains to be seen, but reading the text really puts a very strong emphasis on innovation. And the underlying reason is, of course, that economies, and the European economies are no exception, have come under pressure to innovate, to put products out there on the market very, very quickly. And the prototypical example for this, and this is why I've chosen this picture here, is of course the development of the mobile phone. The mobile phone industry has a very difficult time issuing new mobile phones. Well, previously it was every 2 years, then it was every year. Now we are more in the order of every 4 to 6 months. And that is a real challenge. This is one of the main drivers behind a lot of international research and technology cooperation, at least in the industry. It's targeting innovation, new products that are successful in the market in ever shorter life cycles. And that is a real challenge. And we see more and more of this happen. And if you're a player in this industry, you do not really care so much about the science anymore. All you care about is where do you get your results from. And then you source these results that you may need for your new product globally. You just take it wherever it is, and it doesn't matter whether it's in Australia or in the US or in China. Actually, there are very good reasons to source it from China, and the reason is that there is a very large market there of users. So it's maybe even better to have it developed there and not in Europe. Okay. So what I'm trying to emphasize is that we see this development that has happened for the last, I'd say it has developed over the last decade, but it's really taking up now. And the reason it's taking up is so this sort of international collaboration across country borders, driven by the innovation needs and not so much by the technology push anymore, is that we nowadays have a very strong support for doing this. There is technology to support this. There is, of course, communication technology that facilitates international collaboration very much. There is much better simulation to design your products much faster than what it used to be the case. There is rapid prototyping. There are now even novel techniques for 3D printing, which make it easier to even have hardware prototypes developed much faster than what used to be the case. So the whole scene of how to innovate is changing. We see situations where international teams are created dynamically on the fly just for one project. So that was simply impossible previously. But it's not something that is only happening in the industry. It's important to emphasize this is also something that is happening in science itself, even in very academic fields of science. So some of you may know these experiments in mathematical proofs where international teams collaborate to find novel proofs in mathematics, and it was successfully shown that it is possible with new IT technology to support harvesting the micro-knowledge of many, many experts who are distributed over the globe, put it all together to create something that is much bigger than this micro-knowledge and to prove novel theorems in mathematics, for example. But much of this is still under development. Much of this will remain to be seen how successful it is in the end, but it is certainly the case that we are facing a situation where the ways to do research, the ways to innovate are changing currently dramatically. And it's really, I think, an interesting question where this is going to end up. So this is what is meant by the post-scientific society. So these are the reasons why to collaborate. But where does this leave science? Sorry, and I want to come back to this one here, future and emerging technologies. Now, some of you may know FET is a very special program. It is a program that addresses radically new technologies, novel and high-risk ideas on scientific foundations. So if you want, this is a little bit of it's the old story, it's the old idea, science pushes technology development. So it is science-focused, but it's at the same time oriented towards technology, which is of course application-oriented. And in this definition already, you can feel a certain tension, right? There is a tension between this idea of being, on the one hand, science-oriented, on the other hand, bringing new technologies out there, which obviously have a purpose. They are not purpose-free. So FET is problem-driven. It's meant to have application relevance right from the start, although sometimes you may not know what this application is going to be in the end. It's supposed to be radically innovative, not just incrementally innovative, so it's really something very new. And of course, all of this implies that you do not really know what's going to be the outcome at the end. There are high uncertainties, there are technological risks associated with it. Examples of what FET has been dealing with in the past would be quantum IT, zero power ICT, I think that was the old title. They changed the title later. Brain-inspired ICT, molecular scale devices and systems. So these are all topics which have in its core something that is science-driven, but where you can, to some extent, already also see what the application might be. So obviously towards zero power ICT, well, that could be really, really useful if we could do that. Right? So the challenges in this area are, I think, rather peculiar. We have this foundational nature of FET. What does this mean? It means you probably in your projects are going to deal with scientists, which is good because you have people who really know what they're talking about. But they may probably not be usually that much application oriented as you would expect. The second feature which makes it good and bad is you're dealing with small teams. So we are not talking about topics that, you know, where you have thousands of players worldwide, very quantum IT, and that's already a relatively large group of people. But this still, there are centers here and there, probably not even in every country. So these are relatively special topics, which sort of makes it probably easier to identify those groups, should make it easier for them to collaborate, but they remain rather small groups. We are talking about very specific problems. So, yeah, again, quantum IT is a very, very specific problem. It's not like developing the next app for your mobile phone, right? And all of this involves a certain communication challenge. FET is not something that can be easily explained, not even to people, I would argue, in research management, for example, and definitely not to scientists. It's not so easy to understand what FET research is really about. Okay? So in this sense, this is the reason why we meet today. It is because FET faces some particular challenges. And our question is, how can we best meet those challenges? If I'm right, if the future of research and innovation is in cooperation, then how can we best support cooperation and harvest the potential of cooperation while at the same time addressing these specific challenges of FET, which probably doesn't lend it nicely to cooperation? Now, from my past experience, I would just, and this is really I think what we should discuss today, so I'm not suggesting I have all the answers. Probably I have actually more questions than answers. But what you could, of course, do here is a simple three-step approach that you could take. And I think it's not something really surprising. So typically you would expect that for FET projects, they progress in like three steps. A first step where you establish contact, a second step where you do the collaboration, where you work on your research project, and a third step at the end, towards the end of your research project, where you think about what you should do next. Okay, so the first step is about getting the right information, getting into the FET program, learning, sharing experience. The second step is about collaborating, expanding the network, building trusted relationships, use networking opportunities. And the third step is then about, so what do you do with all these relationships that you have created? How can you leverage them? And what can you take home and build on for your next projects? So on establishing contact, what I'd like to say, and this is now from, I think, roughly 15 years in international research cooperation management. In this first phase, I believe there is a strong public role. So there is a role that the public has to play, and with public I typically mean ministries, I mean research management organizations. Here in Hungary, for example, it would be people like Edina, who many of you know and who has supported us a lot in organizing this conference. Thanks, Edina. So it's it's this role of organizations. They don't typically do research themselves, but they act as intermediaries. They bring researchers together. They inform people, for example, that there is such a program as FET. Okay? It's a very peculiar profession. It's a profession where, and I'll come back to this actually, you yourself typically are not a researcher, but you help other researchers, you facilitate them. There is this other aspect that you have to have someone which is neutral in a sense to all of research, who does not have an own interest in, for example, giving preference to one group or own collaboration. So typically my experience has been, with a few exceptions, but that people who have this job as an intermediary should not be researchers themselves. Okay? I know that in some countries this is different. So in some countries it's researchers who are tasked with. I think you need to have a good degree of split personality to be able to do that, but then again, many people maybe are able to do that. So it's really important to have a trusted information service. On the other hand, so this is let's say this is the information dissemination pathway from, for example, the European Commission to the researcher, but there is a much neglected and very important pathway in the other direction that goes from the researcher to the European research community. If you're a newcomer in different areas of science, well, of course you are not very well known. People in, I don't know, Spain, France, or Lisboa may not know about what you're doing. And I do think this is particularly true of the EU13. I mean, I'm a research strategist, so I'm supposed to know at least a couple of areas where some countries have strengths. And I would say even I, despite of an original interest in the subject, I do not have a very good picture of the EU 13 countries and their specialities, their strengths. There are a few exceptions. Fortunately, Budapest, for example, is one exception. I had the pleasure of visiting the technical university, so I know they're very good in embedded systems, for example. And there are these pockets, I think, in every country. But it is actually a task, it's actually an effort to get this knowledge out. This is public relation. It is something that needs, that's work. That's quite simply, it's work, and it's also, it costs something, but I think it's worth it. So there is some active PR needed, and there is also something else which I think this is important for all countries, but it's probably particularly interesting for EU 13 countries. You can build on your colleagues who have, for example, left the university, or people, your students, that have spread probably all over the world, but that you can now find in your in neighboring countries or all over the EU. These are typically contacts to exploit, to build on for further contacts, because they have the twofold advantage that they are already sitting in the country with whom you probably would like to build up cooperation, and secondly, they are probably related to your research interests. So these are very good candidates, and that's something that is not just true for intra-European collaboration, it's also true for international collaboration. For example, we have done a study of Australian collaboration in the EU program, and it was absolutely evident that many of the cooperations that exist nowadays, they actually come from former student professor relationships or colleagues working in a team. It's just that the students may have left the country, or they have moved to another research organization, and this is what is the nucleus of successful research collaboration. So that's about establishing contact. Now, let's assume you have a research project, you have a successful FET project submitted. Then, of course, not every project is equally successful. What you obviously need is the right mix of people. But for good collaborations across country borders, typically, and we have analyzed this, so this is not just from the top of my head, we have actually looked into this systematically. What you typically need is you need key individuals as drivers. What does this mean? It means you need to have someone, an outstanding researcher, an outstanding personality, someone with leadership capabilities, also in research, who leads the project, who drives the project to maintain the collaboration. Otherwise, what you get may not be completely unsuccessful. I mean, still, if you don't have this, you may get some sort of collaboration, some nice working together. Everybody does what he or she has to do in the project. That's fine. But you do not typically get these very successful, outstanding results which arise from a team collaborating towards one jointly accepted goal. That is the reason why you need this leadership. The leadership makes sure that there is a vision that everybody shares in the project. And this is very important in scientific research, because otherwise, well, if you're a scientist, you have your own field that you're interested in, and everybody has their own interest. And this is why this joint, shared vision is really important if you want to achieve something great in a research collaboration. Unfortunately, developing such teams also requires some effort. And it is probably easy to understand that if you devote some time and effort to building such teams, you are more likely to get good results. That's not rocket science. Basically, what you have to do is just you have to sit together, you have to attend the meetings, you have to travel, you maybe have to devote a little bit of thinking, well, how can we build partnerships, how can we do something together, maybe something non-scientific, non-work related, but it's these things that build strong teams, and they are as important in industry as they are in research. Longer exchanges is an important tool for achieving this, so something that goes beyond just a couple of days, weeks, months of exchange visits typically do the trick. Another thing that is probably underrated, because we all have so many things to do, is exploiting networking opportunities. There is a plethora of networking opportunities offered by the European Commission, by national authorities. There are conferences, there are meetings, there are events, there are publications. The trick is to make best use of this. It's easier said than done. You need to have a good feeling for which are the important meetings, which aren't. But I do think that most researchers are not very good at exploiting these opportunities. So typically you're just interested in giving your presentation and getting feedback. But there are many other conferences where you can meet important people, where you can build partnerships, where you can leverage your project to another level. But again, it involves a bit of thinking, it involves a bit of understanding what works best and what doesn't. And in the end, it comes to building reputation. It comes to building an awareness of what you and your team and your institution are capable of. And this is something that stays for years and decades. It's something that stays in your home country and obviously in the EU. And which is, of course, important for follow-up, for deepening partnerships for the next phase. So one recommendation that really we can give, although I have to say we are not always doing it ourselves, is to start follow-up actions, to think about new project before the project ends. Okay, what can you do next? What are the questions that come up from the research that you've just undertaken? What are the partners that you have just met and you would like to work with? Why don't you sit together and think about this? Not so much driven by calls of the European Union or calls in your national program, but driven by the needs of the market, the needs of the research field you're working in, or the discoveries you have just made. So look for topics and partners before the calls, discuss them with peers, with outstanding experts, not just with the colleagues home at your universities, and also discuss them with your policymakers, discuss them with, I don't know, your multipliers in Hungary, with EDINA. I think many scientists are not extremely happy, to say it in a friendly way, with their research policymakers. On the other hand, we are often servicing policymakers in helping them to identify strategies for helping their researchers, and it's really difficult to keep this communication going because, well, policymakers typically are not scientists. They need to be informed. They need to be told about what are the interesting areas, where are the developments, where are the markets in the future. So this communication is really important, and I know from, it's from the European Commission or the ministries in my country, it is actually hard work to get scientists to tell them what they really want. It's not so easy. In the end, I think what is probably the most difficult challenge in research collaboration is leveraging peer-to-peer collaboration to the group level. Right? In science, and that's also particularly true for FET, which is very much science-oriented, in science, peer-to-peer collaboration is sort of easy. You read a paper, you contact the person, you can have an academic exchange, and you feel connected because you're working on similar problems. That works very well. Country borders are not important, and actually they haven't really been for the last 100 years. But after having such a peer-to-peer collaboration, building on that to leverage it to group collaboration where the individuals are no longer that important, that is not easy. That often doesn't work. And that, of course, means that when this peer person is leaving, the collaboration breaks down. Or it's just shifted to a new organization, which can also be good. But it typically means that even if there is a good group behind, this strong collaboration may not be continued. It may not go anywhere. Why am I saying it's very difficult? It's difficult because the means for doing group-to-group collaboration are rather different from when you do peer-to-peer collaboration. Group-to-group collaboration can be supported by, for example, having a joint lab. Whether that's a virtual lab or a real lab, of course, makes a difference, but even a virtual lab may help to give your students an entry point, to give them a reason for talking to the other group. Or exchange programs, longer exchange visits, where you have people from one institution visit another institution. So again, these are results from our analysis, mostly of international research collaboration, so even intercontinental research collaboration. And this is something that is never easy, but it can be a means to really make your group not just visible, but successful in the long run. And I think this summarizes my views at this point, at least, for international collaboration and strengthening participation.